Yo, 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 good morning, good morning. I'm just gonna jump right into it. No stream yesterday, had a planned power outage, so we're gonna continue the tessellation today. Hopefully get to the bottom of it. So for you who have been watching the last 1.5 week of streams, we've been focusing on the tessellation part of mainly the snow actually, but if we can find a great solution to our problem, we're gonna apply it to the water, the ground, and the snow. Everything is gonna be way more optimized, performance-wise, and improved visually as well. Hopefully, it all comes down to there are multiple things we're trying to solve, or get rid of, or fix. But the main one being jagged edges when you have a steep edge, pretty much. So we have pretty much, instead of doing a quad-like, where each quad consists of 2 triangles, I'm trying an approach here where each quad consists of 4 equal size triangles, just like this. And we would like to tessellate this in a very nice way. Best way possible would be if we, for each tessellation level, pretty much splits each triangle into 4 triangles, much like the Triforce in Zelda. And the means to do this is very limited when it comes to tessellation shaders. We have a few different options we can play around with, but it's mainly going to be up to partitioning and whatever number we give the edges here. But, like, I found this from this user, which makes me very optimistic. Because if we take a look at this one right here, that is pretty much something we would like. So we're going to jump this one, and then I guess it's down to this one. If we could get something like this, it would be amazing. According to this diagram, it should be outer tessellation factor of 2 and inner tessellation factor of 3. Hope it works like this for my hardware and in HLSL, but we will do some experimentation. So we're gonna start by, we have tessellation amount. I want to split this up into tessellation amount outer, but let's change it throughout the shader. Don't we have... some reason that doesn't want to work. Let's just do it like this then. Tessellation amount outer. And then we're gonna have tessellation max and then we do an inner as well. Let's play by the same rules. We do it like this: output edge 0, 1, 2, tessellation amount outer, inside tessellation amount inner, and then I'm gonna go with partitioning integer. You get more of a popping instead of sliding. That's what I want. I've also thought about quite a lot about this topology right here, and I like it more and more. If we take a look at how to calculate normals, for instance, we will always go with left upper, top right, bottom left, bottom right, and that works for all nodes. Some nodes have 6 connected neighbors, while some only have these 4. But if we limit it to these 4, we will probably get a little bit of a better overall normal calculation. But that we're gonna have to find out. First of all, I want to get the tessellation in place. If we can make something that looks like this, it would be amazing. Incredible, actually. So if we try with the same as the diagram, we should have an outer of 2. And we can see here, if we go 2, instantly we split each outer edge into 2 edges. This one for this edge, this one and this one for this edge, and this one and this one for this edge. We don't split the inner here. Hopefully we can get some better understanding of the inner triangle later today as well. If we go 2 here, nothing changes, but if we go 3, we get this. Not entirely sold. Let's see here. It's pretty much exactly the same as the diagram. We will get this shape here, which sucks. But let's see here. What are we looking at? Yeah, we get... we get a bit too many triangles. This is good. We can experiment with this. 3. Don't like these shapes at all. I wonder what would happen. Let's do this. So for this one we have, what we have, we do quad generation. We would have to do, let's do, let's do terrain tessellation, triangle test. Quad test. Good morning, Harukanan. Thank you. Thank you. What does it actually complain about here? Okay, there we go. Now we have one quad, one triangle. Does this one work? Ish. Not really, though. Still getting triangle-like. Because we're using the triangle material. Let's do this. Let's change this to quad. Let's see what we have. Did I screw up the interpolation? Possibly. Interpolate by linear. It's fine. Yeah, we need to double check that as well, but that's okay. Okay, there we go. I want to have them both here. 1-1 normal quad. I wonder if... Now I want to have more control here. So we're gonna do 1... Okay, let's do the same with inner, actually. We actually have one more. Down here, yeah. There we go. I'm wondering if we want to do something like this instead. Instead of relying on triangle tessellation, we do quad tessellation, but we have some insane control over it. So then I wonder what happens if we do 4, 4, 4, 4, 2, 2, 3, 3, 4, 4, 5, 5, 6. And then we're yeah, then we're screwed. Like if we do 2, 2, 2, 2, 1, 1. Starting to look good. But as soon as we go one more here and one here, we're gonna start seeing this pattern. Yeah. Wonder if it depends. Oh, 2. Yo, also Catboy King, thank you, appreciate it. Fucking hell, these tessellation patterns we get. Seriously don't know what to do about them. I guess this is the best we get, but this is gonna render as shit. At all levels. 3, 4, 5, 6, 7, 8, 9. I really don't want to implement my own tessellation just to get a nice pattern. It seems this one is almost perfect. Would like to skip these lines here. But those lines are probably... I'll most likely never be able to get rid of those lines. Yeah. Might be worth looking into. Mm. Like, yeah. This is pretty much exactly what we want. Would really not like to rely on geometry shader. Mainly because of this. These shapes. Let's go to triangle test and do the same thing here. I want outer. We're gonna do better naming here. So we're going to call this one outer 0, outer 0. One, two, 1, 2. What do we have? So then we split this one. Every time we split it, however, we get... Yeah, we pretty much get this split no matter how we do it. Guess that makes sense. Could we build the original... Could we build the original triangles in such a way that we get... Yeah, fuck, if we just do the classical of splitting it here, and once here, once here. These names, but let's see. Done this so many times. Should have... I have this summary, I do. Now we just have to convert it to this. What did we do? Subdivision 1, then we don't do anything. Think. But we want the last one here. Or if we want to do this, so I goes between 0 and 1. This one is 2. Thing like that. If we have one resolution subdivision, Reckon the first split will be nice, the second split will be shit. If we don't get an out of bounds error here, though. Something of the sort. Okay, we don't get anything. Subdivision amount 1. Subdivision amount 1, we get 2 here. So we get 3 times 3. 9, that's correct. That's the number of vertices we want. Yes. Dimension. Okay, so this one might be wrong. Subdivision, so we had 2 here. 6 times 2 times 2. 24. 3, 6, 12, 24. One sec. 1, 2. This should be okay. Divided by 2. 0, 1, 2. Did I screw up something else? Will codes, what up, what up? This one still works. This one does not. Oh, yeah, we never set the vertices. Fuck, how do we want to set these then? It feels like we're filling up height. I think we just need to do it like this, right? Vertices is equal to. Oh, whoop. Okay. Are you fucking serious? Okay, so when we do... Jesus, let's go 1. Jesus fucking Christ. So when we split this triangle in 2, we always get like this edge here. What the fuck? If we do tessellation here and we do 1, or actually 2, 1, 1, and 1 inside, I would like to see just a straight line like this. Not very fond of these. Yo, what's up, Bruce? Why is this the pattern chosen for Tessellation? Hate this. Look at this one. Here we get a triangle on the inside. That is quite nice. Here as well. Two, two, two. 3, 3, 3. 4, 4, 4. Pretty much like this type of pattern we see here is never gonna lead to any good shading up close. Fucking hell. And this one is fucked from the get-go. Here though, if we do quads and we split inner by 2, we get such a good start. This right here is beautiful. But I have no idea. Three, 3. N, we get n minus 2 squares in the front. Or n minus 2 to the power of 2 squares. Is that so? 5, 5, so then 9, yes. 6, 6. N minus 2 to the power of 2. 6 minus 2, 4. 4 times 4, 16. 16 squares. Let's just fix this one. Shuriken pattern. Yeah. What am I missing here? Feels like every damn pattern we generate, we can generate a whole set of different nice patterns. But no pattern we have seen so far really does it for me. All I see at all times are shadow artifacts, normal artifacts, and worst case scenario, jagged edges. Yeah. So here we probably want to go, do we want to go Subdivision 2. It seems to be the first one. Ooh. Ooh. Yo, what's up, Cooler SK? Thank you, appreciate it. I'm missing. First one goes. Okay, so let's go here. We populated height first here with first here, unfortunately, but whatever. So then we take this one, then we go up, then we go to the right, then we take right. What is wrong here? Ooh, one. One, we get 2, and we do 0. Do we want to go, so if subdivision is 2, like I wonder if we want to go subdivision plus 1. This one is correct, isn't it? Yeah, it is. Subdivision. Could it be 2, 0, 1, 2, 3? Are we gonna get out of index? Possibly no. Okay. And if we do tessellation on this one, fuck these splits right here. I hate them. I hate them so much. That is a beautiful cooler SK. Come on. If we take a look at this one again, there is no way around it, is there? Unless we go off script a lot. I wonder. Output control points 3. I found one interesting. Let's see if I can pull it up. I want to take a look at this one. Look at this right here. This is exactly what we want. What do we have? What's this? E and triangles. Yeah. Patches, high order normal variation. Fuck, I would love to get triangles like this. Triangle setup. Huh? Okay. Holy fuck. Like, if we could achieve this type of triangulation, nothing would be able to stop us. If we could achieve this in the tessellation shader, that is. Holy fucking shit. Silhouette, yeah, like, I'm not so... My main focus isn't getting the curvature. In our case, we're probably gonna skip the curvature most of the time. I just want the subdivision. Like, subdivision in like this in the tessellation shader. Perfect. Yo, what's up, Namida? Thank you, appreciate it. Geometry coefficients of the PN triangle. PN triangle. This is what I'm wondering. Can we get great tessellation if we loosen up on this constraint? And instead of working with 3 points, we can skim this and then see how the GitHub repository solves it. Let's do this, though. Direct 3D rendering cookbook. Yeah, curvature. I don't care that much about it at this point. This is old school. No. Hull shader, PN triangle patch constant. Here we have the test factors. Interested in what they are set to. But then we also send in a lot of positions. We're talking about B210. So we're sending in all of these positions, right? 3, 6, 7. Not really. We're sending in the outer, or this one at least, this one, this one. Oh, yeah. Is that so? This one, and this one we get. And then we send in 7. These. This is center. Row. What's up, Jones? Thank you for the raid, appreciate it. Hope you had a wonderful stream. Yeah, over on this stream, we are... I don't even know where to start, honestly. It all goes back to terrain, snow, etc. And we're trying to tessellate our meshes in a very specific way. Turns out it's a little bit harder than we want, but we're optimistic. Crow's Eye over on YouTube, what up, what up? If you don't mind me asking, what are your plans for music? Planning to do some solo dev as well, but not sure about music. Fuck, music is hard. I think I have a list of different aspects of game dev, ranked from what I enjoy to do most to least, and what I know, or how I know to do something. And I think music is like in the bottom. I will probably try to... I'm probably not even going to try and do it myself. Joes, thank you, appreciate it. The problem we're trying to solve basically is that we have a mesh. We have multiple meshes actually. We're doing a lot of experimentation here. So we generate a mesh like this, the classical quad split into 2 triangle topology you see so very often. And then we actually have the same, or we have one where we just generate, so in this one we handle the mesh as triangles, in this one we handle them as quads. If you handle them as quads, you can get some nice, although we have a visual glitch here, but if you handle them as quads, you can get some nice subdivision like this, which we used to rely on earlier. The only problem is when you get quads like this, quads that are only split as 2 triangles, you can see you get a very jagged end result when you start displacing this. And that sucks. That does not sell snow or water or terrain good. So what we have tried is, like, the end result, what we would like to see here is a mesh that is more, that has a topology like this. So each point has at least 4 connected neighbors. If you displace this one, you get a much smoother result. The problem is though, like when we generate the terrain or snow or water or whatever, we want the original mesh to be very low resolution, as few vertices as we can get away with. And then we want to rely on tessellation to improve the resolution of it, basically. The only problem with tessellation, as far as my knowledge right now goes, is that it doesn't really... We don't have as much control over it as I would like. So yeah, this is high resolution. If we displace this, it will look mostly fine, but you will have... This one, for instance, will look like shit. There's no way around it. So this topology here, bad. So what I would like to see is if we could start with a mesh like this and tessellate it in a triforce pattern, i.e. we go from this to this when we subdivide. Like if we could achieve this, then I think we can create some wonderful things. So right now we're reading this paper because I want to rely on this implementation. This is mostly for, as I've understood it, to get smoother areas. You want to bend triangles pretty much. But the subdivision they talk about piqued my interest. So I don't even know if this leads us to what we want, but it's worth a shot. Because if we take a look at the default tessellation you get with different settings, you never really get something that is useful for us. So no matter how we split this, we always get these lines right here, which I hate. Yeah, that's pretty much it. Domain shader, control point input, hull shader, triangle patch constant. We send in a lot of information here. And then they implement this one. Let's see if I can find it. Yeah, we pretty much just have 1, 2, 3, 4 definitions of this function with different with different partitioning setups. But let's see if this gives us what we want. Okay, so this is basically only, we don't have the vertex or fragment shader here. We actually do 3 control points, but let's see. This one. What do we do here? We give tessellation factor. I probably want to take a look at this one. which I guess is in here. Okay. I wonder if... Fucking hell. Okay. Maybe if we... maybe we can do a custom solution here. 2, 2, 2, 2. How many new vertices do we have here? Or if we go 3. Hmm. B2 and so here we calculate. Ah, We're gonna see if we can go and find this function eventually. We use this one to calculate these factors, but then we do calculate P and triangle coefficients. P1, P2, P3. So these ones, I reckon. We do the same with normals, and then we calculate control points. P2, P1, N1. So here, in the patch constant function, we calculate all of these points. And then we send them onwards to the domain shader. Fucking hell. Normals as well. We calculate these three. So we don't change these, do we? No. Very interested in this one. Pixel shader input. Oh, fucking hell, there's a lot of math here. But maybe I'm optimistic about this one. Yo, what's up, DevSpios? Thank you for the raid. Appreciate it. Have a good one. The only thing with this tessellate P and try, I'm having problems wrapping my head around is, so what it seems to me, actually what I think, I'm starting to think that we're gonna get tessellation like this, and then for each of these triangles we do the Triforce pattern, which I don't know if that will help us actually. Although, if we instead rely on, if we rely on this one instead, one sec. You get way more structured tessellation with quads, that's for sure. But yeah, it would help us a lot here if we could do this triangulation here. What the fuck? Am I missing something here? Like what I'm scared of is that we do triangulation here the normal way. And then with all our extra stuff, we start dividing these triangles. So we get this and this and so on. And I mean, these Triforce patterns, not very helpful. In the quad case though, in the tessellated quad however, then these patterns are extremely helpful. Let's see. Domain. Yeah. So my next question is, could we do quad try? But if we do quad, then we're gonna miss it would be maybe. So we do quad, but how the hell would that look with... Yeah, I think we need to match. Yes. Oh, I've been down this road before. These two needs to match, so we can't do 3 points. 4 points. We get this, and what do we actually do in the domain shader? But. I wonder if it triangulates triangle in question. We get this fucked triangulation. We get 1, 2, 3, 4 new points in this case. 4 new points. We want 7 new points. But if we triangulate it like this. Okay, so this is when we get 4 new points. 1, 2, 3, 4. If we do 3, 3, 3, 3. Here we get 1, 2, 3, 4, 5, 6, 7. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yo, what's up, Cypher? How you doing? How you doing? One, two, three. It's hard to see here. 1, 2, 3, 4, 5, 6, 7. Could it actually do some magic with this? Could we... Could we restructure these points doing this type of interpolation in such a way that we get the Triforce? Just throwing off your counting, but it didn't work. It's hard to do in text. All good, nice to hear. Same here, same here. Can't complain. Was dabbling with Unreal Engine. Can't be arsed with it. I haven't done anything in Unreal Engine for years. How was it? If we move around these points, like my question is, okay, this might be extremely weird. Wonder how much normal recalculation and stuff we're gonna have to do, but if we do... Actually, let's do it here. I'm gonna go this deep, yeah. One sec, we can do this. Okay, now I'm just gonna have to be... Now I just need to recreate whatever the fuck this is. So we have a lot going to the middle. Right about there. Nice, but very heavy, so to say. Yeah, that's my experience as well. I think I understand. And we have 2 splits. I don't even know if we can get this perfect, but... Um, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. We always get 7 new points. 2. What am I doing? Okay, so my question is... I got a couple of the current Unity sale bundles. Oh, any nice bundles out there for sale? Okay, so we tessellate it with a setting of 3332, which gives us 7 new points. I'm not reading this wrong, right? Or it doesn't really matter what this one is. We'll see. 1, 2, 3, 4, 5, 6, 7. The tessellation we get is... What do we have? The tessellation we get, I'm gonna try and do this as nice as possible. We get this, and then we just go out. And we actually go from this one as well. Doesn't look very good. This is gonna be... do this, and I don't even know if... let's verify. I want to know if we have... Is it something like this we get? Yes, it is. 1, 2, 3, 4, 5, 6, 7, 8, 9. What I want to get is... What did we have? Not the best shapes, but 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same amount of points, same amount of triangles. 1, 2, let's go. 3, 6, 9, 18. Did we actually get 19 here? $18 and 18. Same number of points, same number of triangles, same number of edges. So my question then is, can we rearrange this shit show into this one in some way? Cypher on Unity Marketplace. Oh, nice, nice. Cypher, is it just because your circle nodes are huge? Wouldn't they all connect to a single vert? Yeah, the visualization here is each circle is a vertex, so even though this line goes in here, like, you pretty much only have one entry and exit point for each node. It just looks weird. But I have no idea. So if we assume the relationship between vertices is set before we get to the domain shader, all we can do in the domain shader is move points around. Then we're screwed. This one has, in this pattern, each vertex has at most, what is it, 6 entry points. This one. And in this case, we have a point that is connected to, let's see here, 1, 2, 3, 4, 5, 6. This one makes out 6 vertices. This one makes out all of the vertices. So we're screwed. But if that's the case, I don't really see the point of this one. Hey, what's up, Calvino? Thank you, appreciate it. I attended a parenting lecture this morning. The baby arrives within a week. Hype indeed, hype indeed. But we went to a lot of those parenting lectures. I think they were very good. I just love the fact that I guess it's similar in a lot of countries, but here in Sweden, I really felt like as soon as the quote unquote government was informed of the pregnancy, they just like swooped in and took care of you. Felt extremely nice. I'm starting to think that this one, we don't really, or this one, it's not a solution for, yeah, it's not a solution for tessellating a proper way. It's more a solution of positioning tessellated points in a curved fashion, which sucks. It took me a while to fully grasp it, but I think that's where we are at. Which sucks. So I wish we had anything in the UK. Isn't the UK... I would actually have guessed that UK was pretty good as well. But if we go with the repositioning route, is there anything we can do with this? No, here we get this split, which sucks. We get this quad-like. Fucking hell, I hate this. I hate this so much. Do we have a proper word for splitting quad into 4 triangles? Topology name. Oh yeah, that's where I know it from. Go to sleep with, we never co-sleep. Damn, Cypher. Yeah, it's a bit scary, but I loved it. Yeah, I don't exactly know what I'm expecting this time around. It feels like we soon have explored every possible way of doing this. I guess hull shader. I guess we could do output topology attribute point line. What do we have? Fuck, I wonder about this one as well. Yo, what's up, Diligence? Most of the time I see 3 here. Mm. Fifth function, thank you, appreciate it. One sec, phone call. Okay, back. Sorry about that. Okay, let's see. Yeah. So when we get to the domain shader, we have the vertices. We can position them on the patch, usually used to offset maybe a bit in the height, down or up, to get a little bit of a smoother surface. So for instance, if we were to tessellate something like this seen from the side, we could use that information to get it a little bit more round, I reckon. But that's not really what we care about at this point. A little bit disappointed with tessellation shaders. I mean, they're pretty nice, as close to plug and play you can get, but I wish I had more control over the pattern. Hmm. I wonder though, if we do quad tessellation, add the geometry shader again, but we do I don't want to introduce the geometry shader, but it could be used to split this, so split every triangle into 2 triangles. Then we calculate this point. Or we could do some very crazy stuff, I reckon. One sec. We could do 1, 1, 1, 1. I don't know how stupid this would be, but if we could do, I need to test it first. What do we have here? 1. Okay, we have this. Let's go back to original. Okay, so I'm wondering, could you have a shader with 2 tessellation stages? Or would that be insane? So the first one just subdivides as quads, so we might end up with we want to go 8, 8. So we might end up with something like this. And then we have a second tessellation stage, which for each subquad like this, so we go back to, just imagine that we are zoomed in now and we get, so the first tessellation stage gives us these quads, which consist of 2 triangles, or actually still quads. But for these, we just do a subdivision of 2 and 2, which means that we split them into these types, which I like very much. Fucking hell. Wonder what performance that would imply. HLSL shader with 2 tessellation stages. HLSL shader. A few results tells me that this might be insane. Link queue. We do. Yo, what's up, Krasenstein? Thank you for the raid, appreciate it. Hope you had a wonderful stream, man. Hope the progress with the card game is going all right. Nah, I think this is... Yeah, now I'm just... hallucinating. Yeah, man, it was good. Prototyped a new game. Oh, really? Interesting, interesting. Okay, let's do HLSL, tessellate, and already tessellated mesh. I think... Gotta bounce. Ait, thank you for the raid once again. Much love indeed. Love it. I mean, this has always been the fallback, although... We already have this in place, most, if not all of it. The quad will be emitted respecting the above parameters. This means the quad will have a triangle winding order appropriate for the direction you want the geometry to face. Yo, what's up, GDs? Thank you, appreciate it. We had a pretty great path forward, which got constrained by the tessellation. Yeah, gonna have to rethink it once again. Jesus, I linked something in your Discord promote channel, the state of my project. Oh, nice. We'll definitely take a look after the stream. Ooh, how do I want to do this instead? Sec though. We're back. What do we have? Odd. Fractional even, fractional odd. It's just, yeah, I think OpenGL has a better name for it. Is this distancing, I think. But I mean, we could rely on this smooth stuff as well. The only problem is, so we make these way more dynamic the closer we get. All of them, that is. The problem would be, our very grid-like, our data is stored in a very grid-like fashion. That comes with the fact that it's a texture. So when we calculate normals, I guess like the offsets in question is pretty easy to work with. Maybe the normals as well, actually. If we want to get good normals, we want to know the offset. How hard could it be to keep? All I really want to keep is the topology of this. Is that too much to ask? Yo, what's up, Reself? Yeah. Trying to figure out tessellation, or trying to control tessellation and failing. That's pretty much what we're doing here. I want to achieve this topology, but tessellated. That's pretty much it. Failing is part of the game. Yeah, this feels like I've been failing a little bit too much lately. This topology is basically going to be the foundation, or I want to replace the current terrain mesh and water mesh with this, and I also want to use it for our snow. If we want to get, like, if we want our normals and curvature to look real good, this topology would probably be the best, or most likely. Like, if we go with, we have relied on, let's see here, this type of topology earlier, which results in extremely jagged parts. If we have a, if our slope is not aligned with the triangulation, we get some real bad looking artifacts. We have been down the route of doing quad flips. So i.e. for this quad right here, we would measure the slope and either keep it like this or flip it. And what this would be is a solution to, or we would pretty much just remove the need to quad flip altogether by, yeah, we add 2 triangles per quad, but it's not that big of a deal. The only problem is, or the problem is, that we can't keep this topology consistent throughout the tessellation stages. What you end up with, no matter what you do, is stuff that looks like this. And I hate it. Absolutely hate it. How would one go about doing if we did how is I wouldn't necessarily say that the old approach is that bad. It's just that I can't really get it to work the way I want it to work. But it's like, it's nice to have that as a fallback, which we already have implemented. So I mean, we have it solved. It's just that I want to improve it, you know. I wonder, okay, so quads and triangles, not that much to say about it. But what would we get? How exactly does what kind of result can we produce with relying on isoline? I.e., with, if we did how would the hardware and HLSL triangulate tessellation done by isolines? Or is that stupid? So in this case, we send down each line as its own, and then we do and we split it in half. Bam, bam, bam. How would it triangulate that? I mean, at this point, we could try. Fucking hell, maybe. So let's do triangle test. Let's see what kind of different results we get. Although, we're gonna have to do some indice handling, I think. Let's see. So we would need to do test quad. We would do lines. Meshes from lines. Why not? Why not? Why not? Why not? Okay, let's see if I can manage to do this in 20 minutes. So first of all, I want to do we can start by doing test quad. Let's duplicate this one and do test line. like that. Test line. We do the same thing here, so we create the same vertices. It's just the indices we have to take control over. So how many indices do we want in that case? Okay, let's do it like this. So we have inner, outer. No. Quad. Yeah, we do it like this. So line. So for each vertex, we want to create 3 lines, basically. To this one, to this one, to this one. Then we jump to this one, this one, this one, this one. We can start with this. Half. It's interesting. Okay, so for each quad, let's see here, the number of quads is... We do... I love diagrams, me too. Resolution for... is this the number of vertices? Yes. So per vertex, so we want 3 lines per resolution -1 times resolution -1, right? So if we have a resolution of 3, we want 2 times 2 times 3 lines. That's 412. 1, 2, 3. Yeah. And then we just do index +2. No. +3. We do... Actually, this is crazy. We want to do 1, 2, 3, 4, 5, 6. 6. So we do... +0 +1, 0. Then we do 0 to 1, 1. So, we go down from here. So we're going to get this. So we take this one to this one, and this one to this one, and this one to this one. But it's 6 here then, isn't it? Something like that. And then in the end, we set lines. We should be able to create this one. I just wonder how it will render. So if we choose a material, let's do MISC. Black material, yes, beautiful. Okay. Hmm. Resolution 4. Okay, let's assume that is correct. And then we do quad, triangle. We can take this one. Line test. Line test. Okay, so what do we need to do? Then I guess tessellation factors for this one. I would have guessed it's just like this. We're gonna try that. And then we just do one, let's call it outer. Let's move down, vertex domain line, or is it ISO line? ISO line. Control points 2. Two. And then we just do lerp 0.5, 2, this diagram tool is something else. So we're talking about draw IO. Lerp. Then we change this one to T. We do lerp T and 2. Triangle output. Ooh. Output topology line. Okay, so we're just gonna get lines. This is probably this is probably if you want to do geometry shader stuff later on. Okay, so doing domain output topology line. But at some point, we can try it. Float 2 ice line. Is it a float 2 actually? Huh. Wonder why. Okay, so then we need to do .x, .x. I'll need to change this to UV as well. This factor, so then I'm guessing edge, what? Float 2. Really? Hmm. Okay. Hmm. Try quad. Nothing for line. Okay. Ah, fuck, I fucked up. 0, 1, 2, 3, 4, 5. Okay. Yeah, so we never return. We pretty much never triangulate this. We triangulate each line eventually. So with a subdivision of 1, we just have these lines. Myself, I'm heading out again. Thank you for stopping by, and thank you for the follow as well. Appreciate it. Yeah, hopefully we will finish this someday. But today's not the day, because I'm also gonna have to bounce in a minute. Was hoping that the progress would be that we would crack the case today. Unfortunately, that didn't turn out to be the case. But tomorrow is another day. I'm gonna have to do some more research here. Starting to think that doing it exactly the way I want to do it might not be possible. So we might have to settle at something we previously had. Something similar to what we had. Yeah, but thank you so much for watching, everybody, and have a great rest of the day. Peace.